Hello, everyone. Good morning. I'm Stephen Varga from Toronto, and I build clusters. And today, we're going to use H5Cluster. And if you provided SSH keys for access, that you should be able to log this into the cluster head node with your SSH login name at cluster.hdfgroup.org.
Stephen, excuse me, could you please make font bigger?
Let's check this out. Control plus, if I recall the key combination. How's that? Is it more readable?
It's better. Mm-hmm.
And let's see if Control B gives us a better view. All right. All right, so let's just do this again. So if you provided your SSH keys, your public keys that we actually uploaded to the AWS account, then you should be able to log into the cluster. And appear somewhere here. So some people will be coming in, hopefully. This is a SPACK-driven cluster, and with a quick list that you can see what softwares are available. And just for your information, there is a large size of bunny running around my room, and currently I'm in Custodes. We interrupt this presentation with vigorous running around. All right, so what you see here is a SPACK system. It's a software system, and it's basically on this cluster is a centralized repository with pre-installed packages. Currently, we just start slow, and we will build up later. And if you take a look at, you can actually list the compilers available if usually that's what you are interested. It's somewhat limited in this case, and using the system compiler of the GCC 8.4.0. And for the reason that it seems to be a good choice between a trade-off, how to say it's a good choice when it comes to compiling various systems, as opposed to like coming with something like later editions of the GCC from 9 and up. You may have some turbulence or smaller troubles. If you wish to select activate some of the packages, then then you would load the package into the system. Say, for instance, you wish to use some versions of HDF5. Currently, we installed 1.10.7. Then either it loads up into the environment or it gives you a choice. So in this current case, there are two choices are available, and there are differences between them, and we can find out how they differ with querying the spec. At least the flags and HDF5. Oh. Doesn't not complete currently. Right. So there are still some minor turbulences in the SPACK system, and the reason behind is that once the repository is installed in a centralized way, currently there is only read-only access to this system. And this prevents some of the it disables some of the mechanism, built-in mechanism of the SPACK system. However, it's on the bright side, it's fully functional, and we can revisit the same question. Let's just go back to the regular account. So in case of once we have some sort of a choice offered, that usually we can pick out the version that we wish to use. And in our environment, then we have the that library path updated for that particular version of HDF5. So what basically this system does is allow us to coexist various versions of software systems. In the case of HDF5, we can take a closer look. SPACK info HDF5 would query all the versions available from 1.810 up to the developer versions maintained by the community. And all these versions come with flags, such as whether the C++ subsystem is enabled or not, whether debug is enabled or the high-level API is enabled or not. And the cross product of these flags or options with the versions that we can see in the left upper corner creates or generates the repository. But the rationale behind this approach is that this way you can pick various versions of HDF5, and in case of the HDF group, they can pick the version that you are working with and able to verify whether there is any discrepancy or any differences between the reported problems and the reference system. Similarly, there are choices for the APIs in use. So for the full options, you can tab complete and see what commands are available to you. The most notables are the find that actually gives you the list of installed packages. It's rather useful. Then the load, where you can load some packages, and one of the options, if you wish to load all the packages recursively that you are to use. To give you an example, if we take a look at the Pi package of HDF5, this particular version, then not only loads this Python package into the environment, but all the dependencies as well. So in this case, like if you fire up a Python and you import H5 pi. It isn't really complete. Well, we will revisit this question later, how to import the H5 pi package, but definitely then it would recursively load it up and make it available to you. All right, so let's move on a little bit to the more practical side. So in your home directory, there should be an MPI example that you should be able to check out with a simple symbolic link, and compiling it, you will get the famous Hello World application. Which you may schedule interactively or batch schedule for some processors. Now, the first invocation will be somewhat sluggish. And the reason behind it is the system is S3 based, making it available in all regions. And in the first part, the relevant region of a hard drive gets fetched back to the nodes and cached locally, and then in the second part, it becomes more responsive. And in fact, this goes to the goes that far that actually the user local, where we keep the software packages, are also kept on the same S3 device. So let's go back to the home directory and the world famous MPI Hello World. And here is srun with various options. And let's discuss some of the gotchas of this invocation of the reference software. So the difference between the two is as you can see here in the first invocation with the capital N, and you can notice that the node numbers are different. Whereas in the second invocation, they may or may not be different. And this relaxed view may have an impact on the performance on some architecture. So in this particular case, sometimes it is preferred to schedule jobs per node and to some CPUs and then execute it. But in some other cases, it is less important how they are spread out spatially on the cluster. Then you could just pick the Lily N, and you more likely get scheduled. Now, what I mean by more likely get scheduled is on a shared system, which you can actually list the available resources. You have some CPUs available and on some nodes, and there there are further way to represent the resources to the sockets and how much memory or disk space to have. And SLURM, and then there is a system that actually can schedule or allow you to share these resources or control the access to the resources, which basically means that you have one large size of a resource which is fixed. You can think of a cake, and this is a way of slicing a cake. And the way how you do that one is you ask for the slice of the cake or a given size. Just to give you an example again, let's go back to the favorite MPI Word application. And in this case, I asked 8 units of the slice with no restrictions which part of the cake gets sliced out. And I did not even specify whether I wanted a one slice of 8 units or just many of them. I just more like requested, if we're thinking of a cake, of a certain area of that top surface. Easy to see, if I requested all the resources, then would give us one cake. And if I took all the resources and further with them, in this case, we have 6 nodes. If I requested 8 of them, then the job gets queued and hangs there till the request, the conditions get satisfied. And most of the cases, this is not what we want. Similarly, there are cases when we're not really, we are not interested where it gets, where our software gets executed. We are more interested in on how many processors it gets executed. And this relaxed approach allows us to, allows the scheduler to slice up that cake or those resources and assign it to you. And this is an important part when you start scaling up an application, that you just take the amount of slice that you surely know that you're going to, or that will allow you to work and make progress. And once that checks out well, then you can scale it up to the actual size that gets the job done. And in then cases, you already know that your job does what it intends to do. So you can schedule it for as a batch job and leave it in the queue. And once the resources get freed, then it's automatically get executed, and then you get the result, which basically is the regular workflow. So in order to schedule jobs, then some way you have to be familiar with how big the cake is. It is unreasonable to schedule for a size 80 cake if we don't have the resource available. If you do, you took your luck, executed, great. But then again, I only just swapped the letters. There are no 80 nodes there. That would be still 80 processes running, but on spatially laid out 80 nodes, which is not available. Nothing gets done. That's just a long coffee break. So this is one of those things that it's worth to look out for. All right. So somehow we have to know what resources are available. And for this one, we have an information utility. And my favorite printout is the the long print, where I actually can quickly judge what sort of layout this cluster has. In this case, there is a partition of home I/O. That just basically means that you can schedule to a certain section of the cluster. So if I added that extra nodes with GPUs and I call it a different partition, then you could schedule jobs to that partition of the cluster, and the number of nodes within. While in this case, seems to be reasonable just to start numbering them from 0 up to the available numbers, and the number of CPUs, which in this particular case, when you're running things on the Amazon, it may be only hardware threads. That's another gotcha. If you work with linear algebra systems, that in that case, threads don't do well. Instead, you have to schedule them to the actual cores, which means 2 hardware threads. But basically, I'm saying here is that if you take a look at the first line, node 0, 0, and you look at the number of CPUs listed by SLURM, then you can see the next section that actually shows you that's laid out in 1 socket and has 8 actual cores and 2 threads. So these details become useful once you run applications or software packages which are sensitive to caches. It turns out if you link against your favorite class, basically linear algebra subsistence or LAPACK, I prefer the Inter math kernel library, but there are other popular ones. Then often what happens is that even if you schedule to 16 CPUs reported here, then you don't see any speed increase. And for the reason is that actually something to do with this cores versus hardware threads. And you will notice a good scaling if you schedule your job to the actual core. And this one has to do something to the internal of the architecture, CPU architecture, something related to the EVX pipelines and how they are laid out actually, and how they channel the data to the different levels of caches inside of the CPU. And sometimes it does matter, make a difference. So this, all of these ones is starting from the top, that there is actually a big cake, a cluster, where resources are handed out to your request. Within a cluster, there are slices, and these slices have properties, and smaller slices possibly within a node, down to a socket, to a core and a hardware thread. And how you request these resources decide how your software gets executed, how HDF5 performs. All right. So in some cases, it is desirable to run an application on a cluster. And you can do that one with this terminal switch enabled. In this case, I just use dash. Oh, this is one of those things when you actually don't really request a resource. So let's run it on So what happened here is that I requested 4 processes parallel on a single machine. And interesting. Oh yeah, it just schedules me to the same node back. So what I was expecting here is to hop to a different node by invoking the bash and the scheduler. It didn't quite happen. And sometimes it happens, but as I hit the Control D, is as I'm exiting the shell, that clearly a shell was invoked. Now another way to actually do this one is just simply hop over to a different node. Right. So previously I invoked some job. That's actually the shell that I'm using right here. And there are ways to actually have a track of it, like what's happening. And this is the SQ program that can give a view at your jobs in the queue and what their status is. As it's expected, the queue is empty now as I exited the shell and nothing is running. So what could you do with a queue? What could you do with a terminal scheduled that way? You could actually run applications. And let me actually show you this. Oh, right here. Just pull this up. I hope that's visible. Right. So one of the applications that actually you could use and run is an HTML-based editor. Code Server by Microsoft and the community is a great option. And this is what you actually see me running in this, or actually that's what the terminal is that you can see on the screen. And it turns out that can give you a great remote experience to cluster if you schedule the job accordingly. Now you have options to do that one with SSH tunneling or currently not yet available scheduling method. And the idea is basically is to tunnel a local port or a remote port back to your local host and then connect to it from your browser. And then you can get the login screen, which you actually can see here. All right, so another way to actually schedule jobs is batch scheduling or batch processing. And in this example that you can see is invoking a shell. It does some task, in this case just runs the host name, and then on a different process runs the some heavy computation for 60 seconds. And you would tell the some details like where to put the output and how many processors that you want to reserve for it and such. In the time period is actually just controls that the maximum amount of time that this job will be running. Right, that's actually oh well, it looks like there are some hiccups here. We're gonna go through it some at a time. But let's move on and take a look at how to cancel a job once it's in the queue. And for that one, we will just we can use the bash bash schedule job. So we can take a look at the queue job. This is the shell that I am using, and one way to actually yank the carpet from under down and under is canceling the jobs. And there it is. And handy utility indeed if something takes longer than expected. All right, so these were the very basics of this cluster usage. And only scratching the surface. What's more important and informative is, let me share an experience that this morning we have gone through. That with rental clusters, it is similarly to job schedulers, where when we're speaking of resources and the resource usage and how they are shared, is an important aspect of cluster computing on Amazon or anywhere else. One of the important, most important part is whether the resources are available to you. And in the mornings, it turns out that requesting large numbers of computers often troublesome. And we had great plans here to create a massive scale of a demonstrational unit, as these clusters can scale up to tens of thousands cores. Currently, our resources are somewhat limited. as we can see. And hopefully after this short presentation, I can see what I can do and how to scale this up to a larger cluster.
Thank you, Stephen. This is the end of your presentation, right?
Yes.
Mm-hmm. So we have time for questions. And there was in chat window, you saw instructions from Gert, because not everyone was able to log in, who sent SSH keys after beginning of the session.
Yeah, let me comment on that. So I have added all those users that I have received after the session started to the AWS, to the IAM accounts. And however, that's another limitation. At the moment, it's rather tedious to add these users to a live running system. But maybe later during a break, we can either bring up a second cluster or reconfigure this one. And that will then automatically bring in all those users. So if you have sent me your key within the last half an hour, 45 minutes, as of 20 seconds ago, I have added you all, so you will be able to log in the next round.
Right. So, folks, what you should expect here. So this is what we're doing here is something new. And with something new, there is always risk involved. And often some work or quite a bit of an effort to mitigate those mishaps. And currently we are or in personally, Gerd and I were trying to do what we originally planned, to bring up a cluster that with reasonable resources and you can have a good experience. And for that one, there is actually a complex structure here, somewhat different from government resources, and still a work in progress, but we try to give you the best experience. So for that reason, if it's possible that I would cut my demonstrations or Lily talk shorter than we planned, and I could get to help to log those people in or help them to log into the system. And in a second stage to expand this system and scale up to some decent cluster with better experience. If you have any questions, then please raise a hand if I can help in any ways. And here I am.
There is in the chat window here a question about mounting something. I'm not clear on what the person would like to mount. I mean, everything you need is already, should be mounted for you. So, and if you can explain what you are missing, then. Oh, someone's home is empty. Someone's home directory is empty.
And do we know?
Oh, yeah, the username is, let's see, it's RMJANUSZ.
All right.
Can you take a look at that? Yeah.
But let me ask you what we should expect, because mine is also empty.
Right.
What should we expect be installed?
Yeah, other than a .bashrc and sort of the usual selection, there is nothing really there. So.
Right.
And we'll get to materials in a moment. You will then sort of git clone, for example, the tutorial. There is a repo on GitHub that contains a lot of the materials, and I will have you do that in a moment. But if there, unless you are other than .bashrc and so forth. There, we didn't intend to put anything there. Yeah.
Right, so the directory is empty. However, in the directory, there is an MPI hello world that you can check out. So if you just list your directory, as you can see in the local directory where you can install some software if you wish from GitHub. And there in the share, I think you can see an MPI hello world. And one way to do that one, if you just symbolically link it to the current directory wherever you are. So the file already exists. This just to keep in mind that only symbol links allowed on this system, as OrangeFS is not fully POSIX compliant system, which is inconvenient, but there is also a good side to it, as this non-compliance allows better throughput.
So Gerd and Steven, we have 13 minutes until the beginning of the session. Will it be enough for you to add people? Should we just wait now? Or start a little bit later?
Whether we can do that right now?
Yes, what do you think? Do you think it's better to bring up a second cluster and then have everybody pile onto that, or do a reconfigure which would flush people's current home directories?
Considering the morning experiences and how things converged and in what direction, I would propose that let's bring up a different cluster, and if that everything is fine and checks out, then we would just move the volumes over.
Yeah, and that's an advantage of this approach. You can just say, hey, let's make a second cluster.
Okay, then we'll wait till your instructions and we'll check in 10 minutes, okay?
Right, just before then, if someone is interested, so what you can do with this one, because yes, you are here and it's not so engaging, so how you can get turn around. So here are some tips. So there is on SPACK, you will find IOR or EOR. I'm not really sure how it's actually pronounced. I prefer the EOR because it reminds me to Winnie the Pooh. And also there is a Max EO, might as well, installed, and FIO. So these ones are all performance for performance measurements and such. Now on the Fabric, this is we could only get to the bare minimum Fabric in the morning for some reasons. The AWS today is very busy, and that having said that one, the IO performance not going to pick up to some insane numbers. So don't have very high expectations. However, you could schedule them. Now, what you shouldn't really quite do is running them on your master login node, although you are not banned from doing that. But if you do, there is a good chance that you overwhelm the login nodes as of today and will slow you down. But what you could do is request a different shell or a different node, or just hop over to a different node. In this case, I'm hopping over to node 1 and schedule some jobs. Now, once you hop over, there may be a little bit of a, how to say, like a little bit of a delay or sluggishness. And the reason behind this one, it's on a completely new idea. The entire system, what you can see here is, okay, let me show you, is a parallel file system. So this is where your logins are located. And this parallel file system is layered on an Amazon S3, which has this interesting property that it's super affordable. The other interesting property on this cluster is that the disk-free utility is lying to us. So the correct one is the PyDF, as I just learned a couple of hours ago, where interestingly, even that one is not showing the correct number, because this one is supposed to be like 45 terabyte. So that's rather interesting. Nevertheless, what I was going to say that this is something new, that we're trying to do something that to place the data volume on a shared S3 based solutions that has a good price, capacity, properties, and a reasonable performance. And if you are interested to measure that one, you are more than welcome. And you can do that one by checking out, say, EOR with SPACK load EOR or IOR, and then once loaded into your environment, then you can schedule it, or you can do it from interactive SRun. And let me give you an example, which actually you can see on the cluster website, if I find it for a moment, or the documentation site, cluster vargaconsulting.ca, right here, and in the documentation, there is some instructions that how you actually can run or request a performance test. Well, in this case, this is a collective execution, so let's go with the independent. There must be something. We'll just correct it. So that's how. So if you are reasonable and you want to share it with others, then we're running here on 2 nodes, and we're requesting, say, 4 processes per node. So that's going to give us 8 into total. We are interested in the MPI IO performance as opposed to, say, HDF IO performance with a block size of 1 megabyte. That's matching with the S3 block size that's underneath this file system is layered on. And the transfer of 1 megabyte with 30 segments, which actually should be multiples of 12 in this case. And we can try a collective and see what happens. So that's going to run a shortly IO tests, and then you get some result back. And then there is the more important part, is like how you interpret these results. So you can do that one. Of course, if you schedule a bigger job, then you have to wait. Right, so actually the block size remains, if you want to scale the data up, leave the block size about 1 megabyte. It seems to be reasonable when you want to get the most performance out, that you match your job, the running job, with the underlying IO architecture. In this case, it's a rental cluster, so it can change from how you bring it up, and you can have some of the properties can be changed. So in this case, we're using 6 IO servers, so multiples of 6 is reasonable for segments, and we can change the transfer a little bit. So maybe we can change it if there is some trouble. All right, we'll look into this one. Similarly, if you are interested checking out the IO performance of the POSIX layer, which is the actual home directory, then you can do that one by running an FIO. And I'm just wondering actually if I can get to the, oh, I can do that one right here. If I open this, Control D. And, somewhere I should have some information on video. All right.
So thank you, Steven. I don't know, maybe everyone, I'm confused, and maybe everyone in the audience too. So we are waiting for Gert to start new cluster, right?
No, Steven is going to.
Oh, Steven. Okay, but we now like, okay, we should stop here and start cluster because we have to start in 3 minutes. So we are behind the schedule.
Okay. So then thank you very much for your attention, and let me take a look and see what I can do.